Hey everybody, I just wanted to make a quick video of how my LPad ESP32 project works. This is a embedded microcontroller and the LPad firmware is loaded on it. This is version 0.76, I believe. So full 30 frames per second animation, a dynamic UX sort of theming, as well as relative drawing across different screen sizes, various things like that. This is just going out and grabbing data from the Yahoo API and displaying some 10-year treasury bond information right now. But this was a project that I really wanted to use to get into more agentic, fully agentic programming. And I decided that an embedded project like this, an ESP32 project, was a good it's a fun project, but it also has a level of complexity that can be that can mimic some pretty big code bases. This is a 20,000 plus line set of code from C and C++. So it's a pretty complex code base. And as I was building it, I was building the techniques that I would use with Claude. So I use Claude Code for the agentic programming to make it more manageable, right? And manageable, what I mean is it should be updatable. It should be enabled to be communicated between different teams. If somebody is a product manager or somebody that doesn't actually know how the embedded programming works, they should be able to contribute to the project. So a lot of that stuff is described in the project that spun off of this, which is now called Purlin. So I have a link to that in the README in this GitHub repo. So the point here is these are all features of the app. These are all plain language features that describe how it works, and it is a tree of dependencies so that the builder, whatever agent is building the code, can iterate across new and existing features and make sure that it's not destroying old features while it's building new ones, and it's keeping architectural policies and security policies and all that various stuff. So that's all, Purlin stuff. I'll keep talking a little bit more about the project itself. So right now, it's written for not just one, but two devices. And this is the same code base with the hardware abstraction layer that has been written into the code. And you'll see in the tree, we actually have this hardware abstraction layer that abstracts the display, network, power, timing, and the touch interface. And so again, it's trying to mimic a lot of the solid object-oriented style abstractions that you'd want to do in real enterprise level code, but it's in a smaller code base here for this for these devices. And so this is a lot of progress in a very little time that I made on this. This took me maybe 3 or 4 weeks of spare time work to do. And it made me realize that I can trust the agent to write good code if I'm interacting with it correctly and if I'm creating a process that gives me more confidence with it. And so, so that's just the first step here. It's great to play around with. I can do a lot of stuff with this platform now. It's got a lot of capabilities, including the graphics capabilities, the Wi-Fi and touch and everything like that. So, and the battery. So this one just doesn't have a battery in it right now. It's kind of bare on the back, but this guy is a fully self-contained embedded controller with the battery, and it has charging logic, and it knows when it's being charged and all that stuff. The battery does not report reliable power information. And so that's a struggle that I've been having, but generally you get an idea of how much power it has. So anyway, fun project. Thanks for listening.